Okay, so my first function was the REM function, which gives you the remainder after division. It's of this form right here for your syntax. So that will give you the remainder after division of A, your dividend, by B, your divisor. Input-wise, you'll always have 2. So it'll always be, you can do it a few different ways. You can have an individual number divided by an individual number, which will give you one result. Um, you can have a range of values divided by a divisor, return the same amount. And then same thing for individually selected values. Um, related function is the MOD function. So right here, you could see -4 divided by 3, -1, -1 over 3, your remainder is -1. In the REM function, your remainder, so your R output will be the same sign as your dividend. The MOD function works the same way as the REM function, except opposite. So it will follow whatever sign your divisor is. So if you were running this exact example in the MOD function, everything would be positive. Something to keep in mind, A and B don't have to be defined as variables as they are in all these examples. They can just run, you can put REM 5, comma 2, and it'll still kick out an output for your remainder. Obviously, this looks a little bit cleaner. Something that was a little bit surprising to me was if you divide by 0, you won't get an error message, but it will give you a output of NaN, which I think stands for not a number. So I can show you that here. So 5, 0, you run that, you get NaN. So that's just something to keep in mind. It could cause you issues if you have this function in a long string of code. Um, and you accidentally divide by 0 somewhere, that could be an issue. So I'll do another quick example right here. So we'll do the remainder of, let's say 1 through 10 divided by 5. And so that kicks out all of your values. Obviously 5 and 10 are perfectly divisible by 5, so no remainders there. Okay. For our next function, I had randi, R-A-N-D-I, which is uniformly distributed random integers. So your inputs, well, actually, for our purposes, I won't get too much into detail, but input wise, you'll have 2 to 3. You'll always have a maximum value and either a grid size or column size. That's the difference between 2 or 3. If you put just 2 numbers in there, well, I'll walk you through it. So for this example, this will be 10 to 5, 10 randi, comma, randi, parenthesis, 10, comma 5. That will give you a 5 by 5 matrix. So that's your matrix right there. So that specifies how many rows and how many columns. To a maximum of 10. As you can see, 10 is the highest value in this grid. So just kind of depends. Works kind of similar to the REM. You can put a range of values, and it'll still kick out the same amount. So the output is pretty much one of whatever you specified. Uh, a related function to this would be rand, no I. I'm trying to find, so right here. And the only difference between this is randi will give just integers, whereas rand will give decimal values as well. Something to keep in mind for this one is if a minimum isn't specified, like if you don't give this function a minimum and it's specified when you're writing your code, um, your default value is 1. So like for here, 1 is the lowest number. It will always give you an integer. Um, Something that I found kind of surprising is the RNG function. You can actually customize all of the random number generation functions, something with seed values. So it's just increasing the randomness of how it draws integers and other things. Um, so if you type that function in, it will increase the randomness, I suppose. So I'll show you an example for this. So randi. So we'll go values from 2 to 12. Giving a matrix of 4 columns, 5 rows. Or I guess 4 rows and 5 columns. My apologies. That's pretty much just how it works. Just a random number generator. It's kind of useful, I guess. Yeah, that's it for me. Thanks.